Consider their computing power the same. The memory size is also 80 GB, and the memory bandwidth matches too. From NVIDIA's perspective, using a new, smaller HBM would... Hello everyone, it's Error here, chasing the deep sea waters from the Gulf of Mexico across the Pacific Ocean. In the video I shared yesterday, I explained how I bypassed NVIDIA CUDA and utilized PTX, a low-level assembly language provided by NVIDIA. Instead of leveraging a high-level language within the CUDA library, this approach enabled us to fully harness the power of NVIDIA GPUs and significantly boost their performance. So, do other fintech companies also? Why not use the PTX method to enhance performance? Is the need for extremely high HBM levels now obsolete? These are common questions. For instance, domestic memory suppliers like SK Hynix are currently offering HBM3E and even HBM4. Instead of relying on these, we could optimize using PTX or consider NVIDIA's other solutions. There appears to be ongoing debate about the necessity of GPUs, which has led to inquiries regarding why DeepSeek chose to utilize the H800 GPU, the specific type of HBM integrated in it, and the future developments required to boost its performance. Let me clarify these points for you. To begin with, let's discuss the current state of affairs. You are currently viewing a GPU available on the Made in China website, which includes a configuration of 8 80GB H800 memory modules. It's listed at a price of $270,000. For those familiar with the details, this H800 is essentially a customized variant of the Hopper GPU that NVIDIA offers. The H100 model is essentially a downscaled version in terms of performance. There's a common misconception that the H800 lacks the HBM3 memory found in the H100, or that it includes it but with a reduced capacity. Let's clarify this first. Currently, you are looking at the A100 series, the A800, and the H100. I'm comparing the computing power and memory bandwidth of the H800 to show you the differences. So you can see the performance difference when looking at floating point 64. When looking at floating point 32, 16, and 8, the performance can be identical. Currently, most big tech companies primarily use floating point 32, 16, and now even 8. The core capability here remains the same in terms of computing power. The memory size is also the same at 80 GB, and the memory bandwidth, as mentioned earlier, when combining 8 GPUs, reaches 3.35 terabits per second. If you look at the DeepSeek version 3 paper from last December, you'll see this in action. You might see the use of FP32 at its maximum, but most of the time, FP16 or FP8 is used for mixed precision optimization. This means the performance related to FP64, as seen earlier, is achieved through such optimizations. Even if the performance is reduced to 1/34th or 1/64th, the H800 can still maintain its efficiency when utilizing this. But take a look below. Below, you can see the interconnection bandwidth and NVLink listed, showing how multiple GPUs are connected. When connected, the bandwidth for the H100 is 900 gigabits per second, but you can see it has been reduced to 400 gigabits per second. By reducing the number of NVLinks from 18 to 8, the bandwidth has decreased. As some of you might have noticed from the video I posted yesterday, the bandwidth has generally decreased when transitioning from the H100 to the H800. Therefore, to better utilize the bandwidth, PTX programming is used for hardware optimization. They programmed at a very low level to address this. As a result, performance improved significantly. While it doesn't match the improvements seen with the H100, a closer look at the documentation reveals that DeepSeek's approach wasn't merely about increasing bandwidth. They implemented hardware-level optimizations and utilized data compression during transmission and decompression upon receipt. This technique effectively enhances the amount of data that can be transmitted. In summary, when upgrading from the H100 to the H800, the computational capabilities, particularly for 32-bit, 16-bit, and 8-bit tasks, as well as the memory configurations, remain identical for both models. However, by restricting the interconnect bandwidth with NVLink, the data transfer bottleneck is further intensified. This is what we call the H800. You need to understand what NVLink is. As I mentioned in a previous video, NVLink speeds up communication between GPUs and CPUs. It is also used for GPU to GPU communication. So each GPU needs to communicate back and forth with its own HBM while also transferring data between GPUs. For example, in the case of a deep learning model with nearly 700 billion parameters, these need to be stored in memory. However, one GPU's HBM cannot accommodate all of them. To efficiently handle this, the GPUs need to be interconnected, distributing tasks among them to enable concurrent read, write, and compute operations, which can then be relayed to other GPUs. Although PCI Express has been the go-to standard, NVIDIA's proprietary NVLink, which is 7 times faster, has gained prominence following their acquisition of Mellanox. You might wonder how NVLink has managed to surpass PCI Express in speed. Fundamentally, NVLink has evolved through its 2nd, 3rd, and 4th generations. The Hopper GPU H100 now supports 900 gigabytes per second. In the Blackwell model, it expands to 1800 gigabytes per second per GPU. This is called the maximum link. They have been increasing the bandwidth linearly. This is done by expanding the pathways connecting the cores. So when these GPUs are interconnected and processing data quickly, they need high performance during communication, no matter how powerful each core is. If there's a bottleneck during inter-GPU communication, it cannot reach full potential. Ideally, we want to fit an AI model, referred to as LLM, into a single system, but they are currently extremely large. This means that the data transfer rate must be incredibly high. In the NVIDIA DGX system, 8 GPUs are installed, and they are efficiently connected using NVLink and NV-switch chips. As I detailed in a previous video, it uses levels 0, 1, 2, and 3 to transmit multiple symbols per second, rather than just binary 0 and 1. By using advanced data transmission technology, you can send combinations like 0001 or 1011 instead of just 0 or 1, significantly increasing the number of bits transmitted per second. Additionally, NVLink has been enhanced by adding more physical links. By increasing the number of links to 6, 12, and 18, they physically expanded the link capacity, applying this to the Hopper architecture. Essentially, it's akin to widening a highway and adding more lanes. Referring back to the table I showed earlier, the H100 maximizes the number of NVLink connections to 18, but they managed to reduce the number of links sent. One way to increase this bandwidth, or even with the same link, would be to use PTX programming. It's likely that DeepSeek compressed and sent something this way. Subsequently, they tightened the regulations further and developed the H20 model. The H20 model similarly makes use of HBM3 memory. As previously discussed, HBM3 remains in use, and even with H20 regulations, HBM3 continues to be utilized from a memory standpoint. Therefore, the same expensive HBM3 is being employed. However, when it comes to interconnects, there are some restrictions on NVLink. In this manner, you can observe the direction it is heading. For instance, the H800 model has 41% fewer cores when compared to the H100 model. Consequently, the performance in terms of 32-bit precision and other related metrics is overall 30 to 40% lower. This is an official announcement made by NVIDIA. There was likely a US regulation allowing for its use. Consequently, they further reduced core and logic performance. However, the memory remains unchanged. This is very beneficial for our domestic companies because HBM3 memory is still included. From NVIDIA's perspective, using a smaller capacity of HBM would require a complete redesign. So essentially, it means they are implementing regulations that specifically address the bottleneck areas. To put it simply, DeepSeek aims to maximize the use of NVIDIA GPUs by leveraging high bandwidth memory through PTX programming. For example, while the core performance was kept consistent, the H800 model was scaled down to create the H100. There are such stories. The parent company of DeepSeek, Firefly, is a hedge fund company involved in financial trading. According to Dante, it is not high-frequency trading, but mid-frequency trading, where trades occur once an hour. The CEO, who is now the CEO of TXK, manages assets worth several $1 trillion. When trying to utilize this, the current GPU is highest to achieve optimal performance. The method involves sending and receiving compressed data to maximize bandwidth efficiency. In my opinion, tech companies might not implement this method since the hardware is already available, and adding this complexity could result in inefficiency. On the other hand, the continuous regulations since President Trump took office could pose a risk to NVIDIA. They regulated the H800 and extended these regulations to the H20. Future models might include features that reduce logic performance for the Chinese market. They could also maintain bottlenecks by reducing the number of NVLink lanes. There are concerns that NVIDIA's revenue and profits might take a hit in this scenario. Experts like Dante cover these aspects thoroughly, so for stock and investment-related insights, please refer to specialized financial channels. In my opinion, if this trend continues, HBM will likely remain unchanged. We might also anticipate a reduction in the number of interconnects. As always, there have been ways to technically circumvent national political regulations. Therefore, although there might be some market impact, I do not foresee any major issues unless a groundbreaking AI emerges. That is why I summarized it again today.